In this video, we're going to pull everything together so far. And this is sort of like a math major type of problem where you might want to explore different types of families of functions. And what we're going to do is we're going to explore some parametric functions utilizing MATLAB over some sort of given domain 0 to t, where t is a value input by the user. And so these are the different parametrics that we're going to explore. So one of which is called the asteroid, another which is called the butterfly curve, and then another one is going to be Archimedes spiral. Probably most of you have probably seen Archimedes spiral before. And some of you guys might remember from either Calculus 1 or Calculus 3 what an asteroid is. Butterfly curve is one of the more unique ones, and you certainly wouldn't want to try to take a derivative or an integral of this. That would be pretty ugly to do, especially with that sign to the fifth. But regardless, we're going to utilize MATLAB to explore these sorts of things. So first, we're going to ask the user to enter a value. And if for some reason the value is non-numeric, or if it's less than 0, we're going to print an error message. Now we're going to create a row vector, increments of 1 to 16. We're going to create a menu for the user. So this is just an fprintf statement. And then this is where our if statement comes in. So we're going to ask the user to enter one of the above. And if for some reason it's not one of the choices, we're going to print an error message. And then if for some reason they pick asteroid A, we're going to need the coefficient A. All right, so, and if for some reason the user enters 0 or a negative value, we're going to print another error message, right? And then finally, we're just going to print the graph to the screen, and we're going to label. All right, so lots of stuff to do here. So first things first, let's start by getting the value from the user. Okay, so I'm just going to call this t end, because this is going to be our endpoint for t. And we're going to say enter a positive value for t. And remember that we're asked to print out an error message. Okay, so we're going to check to see, first of all, if it's numeric and also if it's positive. So we're going to say if, for some reason, t end is less than 0, then we're going to print out an error message. And we're going to say value is not positive. And then we're going to say if not is numeric, for the value of t end. Right? So if for some reason they enter a character or something like that, then we're going to print another error message. And actually, we could just say else if we chose to. And we're going to print another error message, and we're going to say value is not numeric. And we're going to end this. Okay, so that's our first error check, right? And let's just run it just to make sure. Couldn't hurt. I spelled positive wrong, but that's fine. So if I have to enter 5, no big deal. If I enter -5, then we get an error message. And then if I enter something like R, value is non-numeric. Okay. All right, so now let's create the row vector. And our vector t is going to be equal to 0. Remember, it was increments of 1/16 and whatever the value of t end is. Right? So if we're looking at our problem so far, we've prompted the user and we've done the error messaging. We've created the row vector in increments of 1/16. So we're done parts A and B. We're going to create a menu now. So we're going to say fprintf, and let's just say menu /n. And we're going to fprintf. I'm going to say enter. I think the first choice was A for asteroid, then B for butterfly curve, asteroid, butterfly, spiral. Okay, so A for asteroid. And we're going to enter B for butterfly curve. And we're going to enter S for Archimedes spiral. All right. And so now we're going to get the choice. I'm going to call that C, and that's going to be input. And we're going to say enter a choice from the above. All right, and let's press all these. Not that we have to, but we can. All right, so let's go back to the error checking. And the error checking says that if the choice is not one of the above, print an error message. All right, so we'll just do an if-then statement inside of here. So let's just go ahead and do this for the asteroid first, and then we'll run it. So we'll say if C is equal to choice A. So what we're going to do is we're going to program the asteroid. And we're going to, first of all, if you recall, we had to get the value of A. And we're going to have to check it. So remember, if for some reason they enter the coefficient A if they select the asteroid. So we're going to say A equals input, enter a value for A. And remember, we have to do some error checking for this. Okay, so we're going to say if is numeric for A, because remember it said that it has to be numeric, and what we're going to do is an error, and we're going to print value of A is not numeric. And we're going to say else if A, I believe it said if it was negative, we had to print out an error message. So it says that if it's less than 0, so enter 0 or A, we're going to print an error message. So if A is less than 0, we are going to print another error message saying that A must be positive. Now, what's happening is this first end is just taking care of the error messaging, right? And this is our first look at a nested loop. Or, I'm sorry, a nested if-then statement. So nested means that there's an if inside of an if, right? And that's perfectly fine, no big deal. Right? Now, the last thing we're going to do is we're actually going to construct the asteroid itself. And our formulas for the asteroid are pretty simplistic. So we have x is a sine cubed t, y is a cos cubed t. So we're going to say x is going to be equal to a times, and I think it was sine first, yeah, sine cubed, sine of t, and we have to do dot q, okay? Remember, it's a vector, so we have to make sure that because we're storing it in this row vector that we use the dot. Right? And then y is going to be equal to the exact same thing, except we're going to change this to a cosine. And then we're going to plot xy. Now let's end this for now. We're going to come back and we're going to edit this. But let's just go ahead and run it. And I'm going to say enter a value for t. So let's just say something like 10. And I did an f print. I forgot the f's here. And while you guys are probably watching that, you're probably screaming at me. You're going to get an error message. All right, so let's try 10. Let's do the asteroid because it's the only one that we have. And let's try 4. Right. And this is our plot, but it wants a scatter plot out of this. Okay, so, but at least we know that it works. So now we can kind of modify it from there. So remember with a scatter plot, we can do this sort of thing. All right, we'll just put an O there, and we need X label, and I'm just going to call it X axis. And let's do a Y label. We'll call it the Y axis. And then finally our title. Let's call the title the asteroid. All right, let's just run it one more time just to see what the asteroid looks like. So I'm going to plug in, let's do 10, and let's check our asteroid, and let's just do something like 6 this time. Right. And notice what happens with the asteroid is that it looks like that it just goes up to 6 and then off to the right to 6. All right, so that's what the coefficient really does, is if you were to keep changing that coefficient A, you're just going to get the same thing over and over and over again. All right, so at least we know that works, so that's good. Let's try the error just to make sure that works. So we're going to say 10 for the asteroid. And let's try something like F. All right, value's not numeric. And let's try 10 and asteroid again. And let's try something like -9, right? A must be positive. So the good news is we're completely done with the asteroid, okay? The bad news is we still have to program 2 more parametrics, and this one's going to be fairly ugly because of the formula. So, but it's not too bad. What I want to do is I'm just going to cut and paste everything. And I'm just going to make an else if statement. So we're going to copy this. And instead of else if, I'm going to say else if, and let's do the butterfly curve next. Now we don't need a value for A, so we can get rid of all this stuff, right? Because remember, the value for the butterfly curve or the function doesn't have a variable A in it. All right, it just has sine t, cos eta, cos t, etc. So let's program this. So we're going to have sine of t dot times, and this is where we go in our parentheses, exp of cos t. And then we're just going to subtract cos of 4t. And then finally, we have this sine to the 5th of t over 12. So we're going to say sine of t over 12 dot raised to the 5th. All right. Now that should take care of everything in here. And I'll probably need one more parenthesis to make that work. Or maybe 2 more. All right, so that's, okay, I see it right here. I forgot to close up the exp. All right, so MATLAB likes it. Now we're going to copy this and we're going to change this over. And the only difference between X and Y is that this is a cos. All right, so we're going to change this to butterfly curve. Great. So let's give it a try, see what happens. Illegal use of end, and probably would be helpful if I had the end over here. All right, so we're going to run it. Let's try 10. Let's try this time butterfly curve, and we have a sine of t. Let's see. Oh, I see what I did. I have to switch these. So, okay, so let's just switch these. No big deal. All right, one last time. All right, and we get our butterfly curve. That's pretty cool. Called the butterfly curve because, surprise, it looks like a butterfly. It still says asteroid on it. So I have to flip these, but that's fine. So I'm going to flip this and flip this. Not that it matters too much because at least it works and that's easy to fix. I'm going to show you if you change that to 100 and then you get the butterfly curve, really pretty. Right? And let's just try 200 just because we can. We have nothing better to do. All right, so what you'll notice is as you keep inputting higher values for the parameter t, then the parametric starts to fill in a little bit more. Now I used 1/16, by the way, to kind of increase the runtime. If I wanted to use a smaller, it would take a little bit longer for it to run, but I probably would get a better picture out. All right, so pretty cool. All right, now the last thing that we have to do is we have to go through and we have to do the Archimedes spiral, right? And this one's probably the easiest one. Right? So let's do this. And I'm just going to copy and paste it. So this one's for the spiral S. And we have our formula, which is T times, I believe it's going to be cos T. So we have X is T cos T and T sine T. Right? So that's pretty easy. So we're going to have T times cos T. Right? And I can probably get rid of that parenthesis and then just change this to T sine T. All right. And this is our spiral. All right. We still have to do some error checking, but we're pretty close to the end of this. So let's run. Let's try 5, and let's try the spiral this time. Okay. And there we go. We get a nice Archimedes spiral. If we do something a little bit more like 10 for our value of t, then you get a better spiral. It's a really nice spiral there. And then you could just keep playing around with this for a while if you wanted to. So let's try with 20. All right, so it starts to become a really, really nice spiral. You guys can play around with this if you develop this on your own as well. All right, so let's just check to make sure we've gotten everything up to this point. And so we've prompted the user. If the choice is not one of the above, we have to print an error message. So we still have to do that. We've printed the selected graph to the screen. We've labeled the axes. We've done the error checking for value A. So really the only thing we have to do is this right here. If the choice is not one of the above. So here's what we do. We just go right here and we say else. And we're going to say error not a valid choice. And let's go ahead and run this one last time. So let's do 10 and let's try something like, well, it can't be B because B is one of them. Let's try T. Okay. And it says not a valid choice. All right, so pretty cool. This entails all of our error checking. It involves our if statements and our control structures. It does some printing of graphs. It does input-output formatting. So it's got lots of good stuff in here of all the different sorts of functions that we've done in the class. The only thing it really doesn't involve is file printing, and we could certainly do that if we chose to.